Okay, greetings to anyone who's watching this video. Recently, a couple of weeks ago, we decided to join in a hackathon. It's called the MedGema Impact Challenge. And the goal in this challenge is to build human-centered AI applications with MedGema and other open models from the Google's Health AI Developer Foundations. It's known that AI has been reshaping the health industry in terms of drugs, like creating drugs or helping diagnostics and so on. But the issue is a lot of these AI models were closed. That means you need to have internet access in order to access their services. But if you know, in terms of, let's talk about Africa or Tanzania in general, the bandwidth in our country is not enough to handle such operations or tasks, because transferring medical images requires a lot of data usage, which is going to be expensive, and also those AI models, to access those AI models is also expensive because you have to pay for them. So our solution is, me and my colleague, we have decided that we're going to try to use these open models. We're going to quantize them so that they can be able to run locally on many machines, as long as they have a GPU. Okay. So we have decided to work on only two of those MedGema variance models. One is called TXGema, another is MedSiglip. One is used for analyzing drug smiles. Drug smiles are like chemical formula, but written in a text format, so that your models can be able to understand them and produce some kind of an insight. MedSiglip is an image classification model. So we're going to use the MedSiglip for trying to, for example, maybe let's say a doctor or an expert in the health industry is looking at a medical image, has suggestion of different conditions that can be suggested according to that image. The model can be able to look at those conditions and be able to suggest which one is the most probable condition according to that image. So yeah, the first thing for me, what I did was create a Jupyter notebook which outlines the steps from installing the important dependencies so that we can optimize those models to be able to run locally. As you can see, to run locally, import the libraries necessary. Then after that, load the first model, MedSiglip, then load the second one, TXGema. Of course, we have to quantize each one of them and optimize. Then after that, we created a pipeline so that we can do two things: analyze images according to this function and be able to perform analysis or insights from those drug smiles, as I said. So yeah, after that, I did a little bit of a test run to see. There's an image I tried to give the of the optimized MedSiglip model. As you can see, the answers according to the list I've given, I gave a normal chest X-ray, pneumonia, pleural effusion, and fracture. And it suggested that according to the image, it's most probably a fracture with a confidence rate of 27. And also try to use the the TXGMA model, and well, it's a lot of text said, but the idea was there was a drug formula written, and they were trying to find out if it can if it can penetrate through the blood-brain barrier. And the answer, it said, if you can see at the end completely, where is it? Yeah, his response was B. And B, according to what I've written, B was supposed to say it can cross the BBB. BBB is the brain-blood barrier, and it has its reasons, such as it said it's a smaller molecule and some other stuff. After that, we save these optimized models locally, so that if we try to build another web application, we can, using Python maybe, we can, instead of having to load them from the internet again, then optimize and run them again, we can just load them from our local files. So it will be much faster for development and for production. So yeah, let me just show you sample of what I'm talking about. So here it's just a snippet of our API. Here this is the API docs. As you can see, we have only 3 API endpoints. There's an health check, there's analyze vision, as you can see, that means it's supposed to accept like a file, an image file, and then of course it's supposed to like give the conditions that we assume that can arise from that image, and then to give a response on which of those conditions is more probable and its confidence rate. And then there's this analyze therapeutics. This is for analyzing drug smiles. So you give the task you want to do. For example, according to the previous example, we are doing a BBB maltins. That means we're trying to figure out if a drug or a medicine can pass through the blood-brain barrier. After giving the task, then you have to write the string, the drug smile, or the chemical formula for that drug. Then after that, here is where you give the instructions about blood-brain barrier and the question that if will it pass or not. Then you can have other additional questions. For example, you can ask it to explain its reasoning, why it says maybe it will pass through, so that you can have more than just a multiple choice answer. You can even have an explanation to its answer here. Yeah, I think that's it for my end. Soon we'll be able to show you the UI, the user interface for this whole project.